Okay. Oh, I got sweet. Hello, everyone. Hope you're having a good day and having a good conference so far. You are in the room where we will be talking about neo4j. So how many of you have played with neo4j? Okay, not many. Very good, because it's a very, very, very introductory talk. And some of you might have seen me yesterday. I did a talk about it yesterday as well. My name is Klug. I work as a software developer / architect / public speaker at a company called Active Solution in Stockholm. And we focus generally, or I've focused my entire career, and right now all of my focus is building custom software on the Microsoft platform. And neo4j does not fit into that picture at all. It's all Java-based, which is interesting. But we started using it on one of my projects, and I've just figured out that it's really brilliant. So I want to do a talk on it because I think there's good things to be had with the software. But yeah, if you have any questions, I'll be around for the rest of the conference as well. So feel free to reach out and have a chat with me if you want to. But yeah, the focus of today is neo4j. So neo4j, for those of you who might not have seen it before, is what we call a graph database. And graph databases are a little bit different in the way that they work compared to our relational database systems. So how many of you have worked with graph databases before? Okay. How many of you have worked with a relational database system before? Yeah. Kind of the way it works, right? Everybody gets started with coding, and the first thing we pull out is, I grew up with SQL, so I've done SQL Server my entire career. I think most .NET developers have done SQL Server. This is a bit outside, and it's interesting because it's actually very simple. Because neo4j only has two little primitives you can work with. They have nodes and relationships. Once you've figured out nodes and relationships, you're good to go. That's all you need to know. I'm done for today, and you have, basically. It's that simple. So we're going to look into that, and we're going to look at how we can work with nodes and relationships and what we can do with it, and what, at the end, we're going to look at some very specific graph-based things we can do with neo4j. But to start off, I want to start in this end. How do we get started? How do we install this thing? Because unless it's easy for me to install on my machine so I can start playing with it, I'm not going to start playing with it. And you have a couple of options. You can do a local install. I love a thing that you can download, double-click, install, you're good to go. And neo4j comes with, you can have it on Linux, Mac, and Windows, so you can run it on any OS you want, which is really sweet. The first thing you have to do is go and install the JDK. And if you've been around a while, you have seen these little pop-ups you get whenever you have a Java development kit on your machine, ever so often. Not touching that. As soon as I saw JDK being nope, not doing that. Let's see what else is out there. Next step is the cloud, right? How about we just leverage the cloud and we use AuraDB, which is what they call it for neo4j. They have a fully managed system for you. You just go in, you sign up. They have a free tier that you can play around with as well. And it's really awesome to get started with. And they leverage this in their tutorial material as well. So if you go through their tutorials, they will give you a database for a certain amount of time where you can do and play and do whatever you want, execute any query you want with it to try it out, and you can just restart the tutorial if you want to get more time with it. Really, really awesome way to do it. Also, very transparent cost for it. So it's zero for the free tier, which is very, very limited in some areas, but you can get away with a lot with the free tier. And then it's $65 a month for the professional and $146 for the enterprise version. That's all I'm going to mention about pricing because I don't care. But we also know that there is no cloud. It doesn't exist. It just means that somebody else owns the machine. And that's fine. But personally, I would prefer to run it locally on my machine because I sometimes go on airplanes and it's really hard to connect to the cloud on airplanes. I have tried doing that coding and doing stuff on airplanes around the world, but connection is really crap. So running locally is where I ended up. I did that really quickly. I'm going to go local because I like it. Now, if you want to run it locally, you have two options. You can go with the classical, which most people in our audience would probably do, is Docker. Docker is sweet. It's really, really simple for you to get started with neo4j with Docker. All you do is you run this Docker command, Docker run, and restart always if you want to, and then you basically have the image and 2 ports. You need to publish 2 ports on your machine. One for actually connecting to the database engine, and one for an HTTP-based API that you can go in and browse and make changes to the database. That's it. It runs on your machine. You're up and running. Oh, and you might want to add in a volume mapping as well, because otherwise it stores the database in the container, and if your container ever gets killed and restarted or whatever, your data is gone. So you probably want to have a little volume mapping in there, and you also might want to set the environment variable to get your authentication set up. If you don't do that, it will ask you for credentials the first time you log in, and it will just set it up for you then. So it's very, very easy to get started. I went down this route and thought this is better than sliced bread. This is just so simple to get started. It takes a few minutes to be up and running, and then I looked at something called neo4j desktop, and now I don't have a Docker container running on my machine anymore. So neo4j desktop is a desktop version of neo4j. It runs on, I think, pretty much all operating systems, and it gives you the database engine as well as some extra tools. So when you start it up, it looks like this. So you get this little tool that helps you out with managing your databases. So you can set up more than one database, and you can get the connection strings and all of that stuff from that, just what you would expect. But you also get this browser. So you can go in and make queries to the database and browse the information in the database, kind of like your SQL Server Management Studio for SQL, but a bit more graphical and a bit more clicky-click if you want to. You don't have to type everything. You get a data importer, because we fairly often want to work with a database that's not empty. And if you don't want to have an empty database, importing data is probably the easiest way compared to generating a bunch of data. And the importer is really nice. You just give it the CSV files, and it goes up and says, oh, here, I've figured out that these are the columns you have, and how do you want to map that into nodes, and how do you want to set up relationships between them and everything. So it's all point-and-click GUI. You press go, and then it imports data into your database. And finally, you get this thing called Bloom, which is a tool for doing data analysis, data science-y stuff on top of graph stuff. No idea how it works. Sorry to say. I'm not a data scientist, but if you are, this will help you, I think. So we'll just ignore that. But you get all the other things, so it's basically a one-stop shop. Download, install, start, database is there, tools to work with it is there. So if we do a quick little, how do we set up a new database? So on my machine, I have neo4j desktop running. I don't think I can zoom this very well, but hopefully, can you see somewhat in the background? Oh, you can't. Let's see if it supports zooming in any way. It does not, unfortunately. Can we go? Oh, look at that. You can. You can just go that. Those of you who saw me yesterday, I'm on a Mac. Never used Mac. Macs are hard. But now it's zoomed at least. Can you see it now? Sweet. So you come in here. I have 2 databases up and running. There's the neo4j default one that comes with it when you start it up, and there's a system one that's used by, the system, kind of like the master database for SQL. And all we need to do is go in and say create database, give it a name. So I'm going to give it the name neo4j demo. Create. Takes a little while. It says refreshing. Now my database is up and running. That's all I needed to create a database. And if we go and say query, connect here and say I want to query it, and I switch over to my newly created neo4j database, we can see things here. We'll get further into this, obviously. I just want to show you high level how we get a database up and running. But out here, we can see what nodes we have in the database. We can see what relationships we have in the database. And if we run something like, if you don't understand this, that is quite obvious that you wouldn't because you haven't seen it. But I will explain all of this. But this basically says, give me everything that's in the database. And if I run that, it goes and says there are no records in the database. OK, kind of what we expected from an empty database. So nice and easy to get going with. Tiny little caveat is that the neo4j desktop runs an enterprise version of neo4j, so you can have multiple databases. You cannot have multiple databases in neo4j except if you go with enterprise. And that's kind of annoying if you want to use more than one database on your dev machine or your devs cluster or something like that. But you can just go ahead and do multiple containers and do port mappings, right? So you do one container for one database, another container for another database, and you map ports, and you're good to go. So that works as well. Not sure I'm supposed to say that, but that's the way it works at least. So let's get back to the what I call the neo4j primitives, the things that we're working with. So as I said, it's different from relational databases where we have tables and foreign keys and things like that. Instead, we have nodes and relationships. And each one of your nodes can have zero or more labels. So labels is kind of one facet of how you can define a node. And you normally use the label to tell it what kind of node it is. It's a user, or it's an employee, or it's a person, or it's a category, or whatever thing you would normally probably use a table for. But you can have multiple different labels on the same node. Then each node also has a dictionary or property bag of data. So it's basically prop value, key value pair store for each one of the nodes. So it's, in my head, it's kind of like a normal document database store. So it's like using a document database, but we also get relationships between our documents. And the schema for this is just like with most document databases, it's schema optional. So we can go and have no schema whatsoever and just shove whatever we want into it, where every node basically becomes a little JSON blob. Or we can go and add a bit of schema to it and say, oh, for this type of blob, or rather any node that has this specific label, it has to have these properties of this type, and actually infer schema into it as well. But out of the box, there is no schema. It's just blobs of data with labels. And then we have the little thing in the middle, which is your relationship. And every relationship has a name. And you have values there as well. So you have a property bag on your relationship as well. So relationships are actual things in neo4j compared to in SQL Server, where if you do a relationship, either you do a one-to-many where you have a foreign key, right? You can't add any values to the foreign key. So you need to have a coupling table in between. If you do a many-to-many, once again, you get foreign key to foreign key to foreign key, but it doesn't give you the ability to add data to the actual relationships, whereas in here, because relationships are a thing, it actually has properties as well. And then we can go and say, hey, I want to find all nodes that are related to other nodes by this type of relationship that has this type of value, which is really useful. So if we take that more in a practical thing, we can see here there's a person node. And the person node has a name and a date of birth, or a year of birth, born. And that person acted in, which is the name of the relationship, in the roles, and that's an array of roles that they acted in, so neo in this case. And we have a movie node with the title, the matrix, a tagline, and a release date. So that's kind of how it works. There's nothing more complicated than that. And once we get into querying, you will see that the query syntax actually looks like an ASCII representation of a ball connected with an arrow to another ball, for example. The property types we have is we can have strings, bools, float, integer point, date, time, duration, and then we can do lists of those things as well. So it's kind of what we have, once again, with SQL, if you're comfortable with that. But we don't have a lot of extra parameters going, say, oh, it's a duration, or sorry, it's not a decimal with precision and things like that, or it's not, we don't have date time and date time 2 to have different type of precision, and date time offset and things like that. Instead, it's just, these are the things you have, and we sort that out for you, and they kind of do in most cases. So if you want to go back to what I said with the relational sort of equivalent of the things we've looked at, so labels are kind of your table names. Because you basically, normally you would have a table called users, but now you will have nodes with label user on it. That becomes kind of but it's also kind of on steroids because you can have multiple labels. So you can actually have a thing that a node that is multiple things, if that makes sense for you. Nodes basically becomes your rows because it's a thing that contains the values for that specific instance of your, well, row, node, table, your thing. Node properties are your values. So those are like the values in the actual columns. And relationships would be your foreign keys, but then foreign keys on steroids because you can go and say, I want to have properties on them as well. And we can also, as you'll see later on, do relationship queries to say, can you please give me the shortest path from this node over here to that node over there using these types of relationships? And then you can basically go through the entire thing and say, oh, the shortest path was this, and I went through these relationships and these people along the way. Or if you want to do like a subway map, you can go and say station A to station B, and you can figure out all the ways you can take through them, and you can have times between stations and things like that on it. So it's a bit different, but still fairly comfortable to work with. And the query, as I said, looks weird when you start. It is an ASCII-based query, and you probably can't see the red stuff that says there. I showed another color, but you do a match. So match is basically like your, not really your select, but it's kind of, I want to match a pattern, and then we'd say what I want to return. So in this case, I want to match a pattern where there's a node with the label person that has some form of relationship to a node with the label movie, and I want to return P and M, so the two nodes. And then it finds all of those scenarios in the database where this works, and then it returns those nodes for me. So working with nodes is kind of what I just showed you. Here is a very simple one. Match n, return n. So I want you to match a node, and I want you to return that node. And the little n thing in here is a variable, basically. It says, I will do a query with a match, and anything that matches in this node here, the first part of my thing, in this case there's just any node, I want you to assign that to the variable n. And then I want you to return all the n's you can find, right? So it means that we can do things like, hey, I want you to return n.name instead. Or I want to return n.name and n.description, because it's just a pointer to the thing that I just selected. For labels, it's a little bit different. So we can go in and say, hey, I want you to match all nodes, n, where n has the label person. So we use a colon to say, I want to use a label on this thing. And this would return any node in the database that had the label person. And these things also support things like and. So I want to have all nodes where the node is both a person and an actor. Not sure how that works, but I guess we have animal actors as well. We can do or. So I want to get all nodes that are either a person or a movie, which is a really weird query to do, because it would be hard to figure out what you got back, because you're going to get a node, right? Yes, but you don't know what the node is. You're just going to get a property bag back, which is either a movie or a person, which are probably going to have very different properties, but you can. Now, I generally don't write my queries with the where clause for this. You can actually do a shorter syntax that just looks like this, that says, hey, can you match any node and assign it to the variable n if it has a label of person? And that also supports the ability to go, I want to have these two labels. Give me any node that has the label person and actor, and give me that back. Or I want to have any node with a label of person or movie, and give me that back. It's exactly the same as a match n where n colon person, but it's shorter and easier to read once you start getting a little bit bigger. We can also match on properties, obviously, because not always is the mapping we want or the querying we want based on labels. We often want to do it on properties as well. So if we just go with match n, where n.name is Keanu Reeves, will give me back any node where there's a property called name with the value Keanu Reeves. Now, that's fine. It's also very scary if you come from a SQL database perspective, because you haven't selected what table you're doing. So any node in the system that has a name property, which it could be quite a few different nodes, right? Okay, Keanu Reeves is not going to be very, very normal, but if you do another type of query, if you just query like this, you might come back and get really weird responses back. Once again, shorter syntax. Instead of doing a where down here, you add a curly brace and go name colon Keanu Reeves, and that gives you the same thing, and it's nice, short, and compact. And you can obviously do a combination. Hey, I want to have this label and this name and things like that, or I want to have this label and that name, and give me that back. Now, before I can start showing you a little bit about how we do queries and things like that, and show you real-world stuff, we need to import some data. Now, if you want to import data into neo4j and you Google that and you end up on their documentation site, they will give you this, which is a flow chart of how you import data. So it's how should I import it? What kind of data? Semantic or app configuration database management or DBMS or just data. And then if it's large volume, you go in one direction. And does it need to be loaded fast? And is it graph data for science? Or is it proof of concept? Is it batching? And then you get all of these different options. Yeah, my only thought about that is it shouldn't be that hard. And for a demo, it's not going to be that hard because this is a demo, so I can do whatever I want. So I'm going to do what you get taught to do with neo4j when you go through their tutorials. You use their movie graph. So they have a graph for you that you can set up. It takes 10 seconds for you to do, and that's what I'm going to do. And then we'll query the movie graph because A, it's already there, and B, we all understand movies and actors, right? And this is actually another nice feature of neo4j is that once you've set up your nodes and you've created relationships between nodes and things, you can actually call a function on neo4j and say, can you show me how data fits together in my application? So this is not data, this is the schema that's in there. So it goes, oh, okay, so we have there are nodes with a person label, there are nodes with movie labels, and a person can follow another person, a person can acted in a movie, reviewed, produced, wrote, or directed a movie. But we don't have to draw our own things, it's just it figures it out based on the data in the system, not a schema that we've set up. So setting up the movie graph is fairly simple. If we go over here, the first thing that happens when you start up neo4j is you get this welcome command here that shows you this little, here's a guide, here's a data set and things like that, and you can click on those. And one of those is data sets. And one of the data sets that they have is the movie one, the one that we get here. And it basically, if you go previous, it tells you a little bit about data in there. If you go next, it shows you, it basically has an insert script. So it's just what you would do like a SQL file with all the data in it. So you take that and then you basically, either you run it straight away or you can press this button. It moves it across into this query thing here where we can look through how they do the insert of all the data. I'm obviously not going to look through all of that. I'm just going to go, that works because somebody made it work for me. And it goes through and inserts all of that data in the database and I'm done. So I'm going to go and close that. Now, we can run some queries on this. And we can either write our own queries or we can use some of the UI stuff. So you might not have seen it, but all of a sudden it went from just having a little star here, which is basically give me all nodes. I don't care what label they are. And all of a sudden, when I imported data into the database, now I got movie and person. And if I click on movie, it gives me a little UI like this, and I can make it a little bit better, like this. No, I wanted that, and I want to do that. And we can scroll in here, or zoom in, and we can see as good as it gets. We have What Dreams Are Made Of, Stand By Me, The Matrix, Johnny Mnemonic, and all of that stuff. And we can also go and say, hey, can you show me all the people in the system? And it shows me that there are actors in here. And I happen to zoom into the only actor that's in there that's not actually an actor, because that's the guy who created neo4j. And for some reason, he is added there and is part of having acted in The Matrix. But if we zoom into anything else, see if we can find somebody we know. Yeah, so we got Al Pacino in here, for example. And then we can click on Al Pacino and we can get some information about Al Pacino as such. But we can also write our own queries, obviously, and that's kind of what we mostly do because we know what we want. So if we go in here and we say, I want to do a match, because I want to match something, and it's like, what do I want to match? Well, I want to match people. So I'm going to go p:person, and I do get a bit of like intelligence-like thing where it goes, here are the labels I can find the system and so on. And then I want to have a relationship. Now, I don't care what the relationship is, so I do --*. It basically says all relationships are directed, so they go from one node to another. And if I go --* less than or greater than, it basically says I want any relationship going from a person to whatever I'm doing, and I don't care about the label or anything like that. Just give me any relationship. And then we can say at the end here, we'll say :movie, because I want to look for any person who was in some way involved in the movie. If I can press the right thing. We'll do movie and we'll do title and we'll keep using the matrix like that. And if we run that, I also need to return something. So we'll return like that. And then we get a little thing in here that says, hey, Lana Wachowski was involved, Lily Wachowski, Hugo Weaving, Lawrence Fishburne, and so on. That's the query that I got. And it's fairly a readable query as such. And we're going to look into way more querying like that, but this is kind of what we do. It's not much more complicated than that. And then, yes, we can also go in and say, if I were to select something a bit more, just to show you this, if we actually return the entire thing, we run that again, we actually get like the relationships and stuff as well. So we actually do get to see how things connect together and things like that. So, but we'll look more into that. I just want to show you how to import the data to begin with. And then we'll start looking at creating nodes, because we're going to start with create, and then we'll go into selecting them and how we've seen selecting, sorry, and we'll go creating now. So creating is the same thing. It's ASCII art. And the syntax is pretty much identical to what we did with the match, right? But instead of match, we say create. So I want to create a node, so I do create parentheses, because I want to have a ball, right? And then I do :person, so I want to add the label person to the node that I'm creating. And then I use that shorthand syntax, curly brace name, Charlie Sheen, and then if I run this, it will create a node with the label person and the name Charlie Sheen. Now, that's fine. There is a little caveat. It always adds a new node. So if I were to run that create statement 9 times in my database, I would get 9 nodes that were identical. Unless I've set up a constraint that says, hey, the name property on a person has to be unique. In that case, it would fail after the first one. But out of the box, if you do a create, it will always create. It will not throw an exception because there's already one with the same properties or anything like that. It just goes, here's a new node. We can obviously also create multiple nodes. Just do one node and then comma, and then we do another node, and then we do a comma, and we do another node. We can add multiple labels to it. So if you want to have multiple labels on your nodes, you just do label, as many as you want. Multiple values, the same thing. In the curly brace, we do property 1, value, property 2, value, property 3, value. It's kind of what we'd expect, in my opinion. And it also supports all the things we'd expect from a database, like order by. So when you return all of the people in the database, please order them by name, or order by name descending. And it has a thing that SQL is missing. They have skip and limit. So basically say, I want you to skip 5 and take 2, which makes paging a lot easier than in SQL, because if you ever try to do paging in SQL, it's painful. Updating is a combination of match and set. So we always work with match to get the thing we want to work with. So in this case, I do match n:person Keanu Reeves. So basically, hey, match Keanu Reeves and give me that variable n back. And then we do set n birth year, set, and then comma n hair color black, and so on. So it's, once again, fairly easy to read. And the match is reoccurring as it would be when you do a select, when you do a create, when you do not a create, but when you do an update. You can remove properties because it's just a property bag. Unless there's a constraint on the label, you can go and say, I just want to remove this property. It's not useful anymore, and then set it to null and it disappears. Or you can go and even say remove birth year, and it just gets removed. Can also do set label. So we do, once again, match. That's where it all starts. Match the thing you want to work with, and then set n.awesome, or :awesome in this case, and say add awesome as a label to that node. Remove, once again, same thing. You can remove labels just as you remove properties. Updating is interesting, because there are a couple of ways to do updates. So this is one, because I showed you the set thing, and that's the one we start with normally. But you also have multiple versions of updating. So this is the other way of doing it. You do merge. So you say match Keanu Reeves and then merge it with this node that I've just created, and it basically looks at what have I set in the second node here that is not available in the first one, and it will merge those 2 nodes and save it for us. But we can also do merge like this. So in this case, we did match and then merge. So we said match this node and merge it with this node I just created. But we can also go and say, I want to merge straight away. And merge here is interesting because it allows us to do on match and on create. So we can say, I want to merge this node here. And then we do a match pattern, like n:person name Ken Reeves. And then we say, if you found this thing on a match in the database, I want you to set the updated and the birth of year. And if you didn't find it, I want you to go and create one, a new node with the person label and the name Ken Reeves, and then set the created property and the birth year for me. So it's nice when you're doing things like modify dates and create dates, because you have easy ways to go and say, should I do a modify or should I do a create thing for me in the same query? But nodes are really useless, because once again, if you just do nodes, you have basically a document database. Once you start adding relationships and start making paths between the different nodes, it becomes a lot more interesting. So the relationship that we have in here forms a path. So a path is two or more nodes that are connected with one or more relationships. And every relationship has a name, as I said, and potentially properties. So if we look at the first thing I did here, that's first match I showed you. It matches any node with the label person with any node with the label movie. And it doesn't care if the person acted, directed, reviewed, wrote, whatever we did in the database. It's just going to give anyone connected to that movie back to me. But if we want to be more specific, we add a thing in the middle here. So if, once again, back to the ASCII art kind of thing, we normally add like a little label on top of our arrow in a diagram, right? And then inside that label, or inside that box, we add the name of the label. We do the same thing in the query. Instead of having dash, dash greater than to do the arrow, we take dash, bracket, name of relationship, bracket, dash arrow, which basically turns it into ball, arrow with a label on top of it, ball. It sounds really weird to say that we do ASCII art queries for a database, but it kind of makes sense once you start working with it. Now, we can also go and ask and set the relationship to be a variable, in this case R, and we can return both the person and the relationship and the movie. And if we were to return it like this, if we run it in the desktop application, it will actually give us the graph being written, like drawn out like a graph thing instead of just individual nodes. But we also need to remember the direction. That is a very small move here, but what you can, so this thing, I wanted to go there. In this case, we have a acted in from person to movie. And then we can go and say, I want to go in the other way. I want to go movie, but I want to have things that points to me. Now, the reason you would want to go in this direction, for example, depends a lot on what you want to do. You want to limit your first node as much as possible. The fewer nodes you get in your first part of your query, the less the database engine has to do how to figure out the rest of the path. So if you have a way to limit your movie node better than you can limit a person, then starting in that end makes more sense. So for example, if you want to go and find anybody who acted in a specific movie, it's better to start with the movie because that's just one node, and then it can go from that one node and find everything else. If you start from the person, like I did in that case, it doesn't have a filter. So it would take every person in the entire database and then start traversing all the nodes or all the relationships to see if any of the relationships in the entire database from any person points towards the movie that I wanted, which is very inefficient. So the direction of the relationship makes a difference. You can also skip the arrow, which basically says, give me any node that uses the relationship with the label name acted in to another node, and I don't really care about the direction, which in this case is stupid because a movie can't act in a person, so it would always have a direction, but you get the general idea. If you had something like this, for example, it's a bit different. So if we say, give me any person with any relationship to any movie, it will, without a direction, it would find both things that are acted in and directed by. So basically we find either direction of your relationship. And obviously we can do things like distinct, like that. Which in this case is a good idea because you would probably find more than one P in this case. You can also go and not assign the variable to a node or a relationship, but actually assign it to the entire path. Say, here is the thing I want to find, which is any person that has any relationship to a movie, but instead of returning just the nodes or returning the nodes and the relationships individually, I can go and assign the entire thing to the variable p, and then it gives me a path back. And that allows me to then go and look at the path and go, okay, so how did you figure this out? Are there nodes in between? Are there relationships in between? What's the entire path that you work with? We can also do things like, I want to have this either-or scenario for my label names, so I can find anybody who acted in or directed a movie, which in the movie database is really useful for the very simple reason that if you just go people in a movie, you get people who reviewed the movie as well, which is generally not that interesting. You can also do more. So I'm going to give you this query here, which is really not very easy to read, and that is partly because I did it on a PowerPoint slide, and I couldn't make it wide enough. And if I did it wide enough, it was so small you couldn't see it. But what we do is we match a person, in this case Charlie Sheen, and then we go, I want to get any relationship called acted in from Charlie Sheen to a movie. And then from that movie, I want to get any incoming relationship called directed. And then I want to get the other end of that relationship, which is a person. And I want you to return the movie and the director so I can basically figure out any movie Charlie Sheen was involved in and who directed it. Which in a SQL query is not hard, but you would have to do a couple of joins, right? But in this case, I do. This is kind of the path that I want. And the cool thing about this is that if you ignore this and you go and say, this is what I want, and you draw it on a piece of paper, that makes a lot of sense. And then you just convert the little drawing into ASCII art, and it gives you what you need. You can also create nodes with relationships, obviously. So if we couldn't create it, we couldn't use it. So if you go create person, Charlie Sheen, acted in, movie, hotshots, that will create, interestingly enough, a bunch of things, because it will create that. It will create the node. It will create the relationship, and it will create the movie. Even if there are already movies with that name and actors with that name and relationships with that name, it will basically go and create a new set of them. So even if I ran this in the system now, it would actually end up with 2 Charlie Sheen nodes and 2 hotshot nodes because it doesn't match them. It says, hey, create this for me, and it creates it. Little caveat is that it wouldn't because this specific database happens to have a unique constraint on the name, so it would fail. But out of the box, it would just create new nodes. So what we generally want to do is this instead, We go and match the person, we match the movie, and then we go and say, I now have this node and I have this node. Can you go and create that relationship in between the nodes? Now this looks really, really like it would work, but it won't, because it will actually create duplicate relationships if the relationship already exists. So now you end up with 2 or 3 or 4 acted in relationships between the 2 different nodes, which is, I guess, not what we wanted. And also, it doesn't add anything at all if it can't find the 2 nodes. It just goes, yep, nothing happened. It doesn't fail. It just goes, you wrote a query, I did what you told me to match this thing, you told me to match that thing, and you told me to connect them. Since I couldn't find that thing, I couldn't connect them, so everything went fine. I did what you told me to do, which means nothing. Not very brilliant, but that's the way it works, so make sure you write your queries properly. So what we want to do is we want to do a match merge. So we want to match the first node, we want to match the second node, and we want to merge in the relationship in between. So what we're saying to neo4j here is I have this node with Charlie Sheen, I have the node with Wall Street, and I want there to be a node, Charlie Sheen node with an acted in relationship to the movie node, and if that exists, create it. If it doesn't exist, if it doesn't exist, create it. If it exists, just don't do anything. So we want to do a match merge when we do changes like that. Okay, let's have a quick look at querying relationships and paths. And let's see if I can get typing down here on this extremely low podium. So let's start out by creating a person. So I'm going to go merge, because that's how we create things in my world. I want to create a person in this case, and it should have name, Chris Klug seems like a good thing. We go play. It goes created one node, set one node property, added one label. That sounds right about it. And if I run this again, it's going to say no changes, no records for the very simple that there are no changes because I did a merge. It already exists. And it says no records because there was nothing to return because I didn't return anything in particular. Now, all of the people in the database actually have a year when they were born, and I forgot to set that. So we have to set that as well. And I'm going to go ahead and use the same query again, merge person, blah, blah, blah. But I'm going to go ahead and add a set. I'm actually going to assign this to P. So we go P dot born equals, and I am that old. So we go play. It says set one property. And if I were to go and look at people, we can do match P people or person, sorry. And we pull out me. So we go name Chris Klug like that. It's case sensitive. And we select that. We should be keep forgetting return P. You need to return something from your query. And then if we look at that, we can see out here that I have a born property and a name property just as we expected. Now, as you might have figured out by now, I am a fan of the movie Matrix. And I mean the Matrix, the one movie they made. There were no other movies made. Can we agree on that? So I'm going to put myself into that movie. So I need to add a relationship here. So what we're going to do is I'm going to say match. So I need to find myself. So I'm going to go person. I'm going to find name Chris Klug. And then I'm going to match the movie that I need. So I need a movie. And it's going to be a title on that, which is The Matrix. Like that. That's not going to find anything. We need that. And then after that, I can say I want to merge. Not Marge, it's not The Simpsons. Merge the node C, and I want to merge it with a, let's see if I can find the right case, acted in the node M, movie in this case. If we run this, it says created one relationship, and if I were to go and run match, we want to match the entire thing, so I'm going to match the entire path that I'm querying. And we'll match any node with the movie tag, with the title, The Matrix. And then we want to look at any person who, acted in The Matrix. And I don't really care about the node label or anything here because it will only be people anyway, so I don't need to add extra stuff in there. And then we do a return P. We run that. You can now see that in The Matrix you find Hugo Weaving, Lawrence Fishburne, Carrie-Anne Moss is her name, right? Yes. Keanu Reeves, Chris Klug, and Emil Ephraim. So that's kind of what we need. Now I'm part of The Matrix. I always wanted that. Now, I mentioned previously that the way you do your first part of the query, like the first node you start from, the more defined you can make that, the better performant your query is going to be. And I know that performance is a thing in SQL as well, but we tend to know how to do that because we add indexes to the columns we include in our query and then we're good to go. We can do that here as well, but it's a little bit different in the way that it works, but it's good because they actually included tools for us to figure out how bad our queries are. So if I take this query here, where I match movie and then any actor in that thing, actually, let's go and say, oh, that works well. Let's do that. If we take that and we go up here, and we can actually add a thing that says explain. And then we run it. And then it goes in here and it tells me, how am I going to do this query? So it's kind of like the query planner in SQL Server Management Studio. So it allows us to see that, hey, it's going to run a unique index to find the movie, and then it's going to expand that, and it's going to do go through the acted in relationship, and then once it's found the other end of that, it's going to project those and produce a result and return back. And we can see here that it estimates that it will find one row in the first part of the query, then 5 rows, and then it's going to return 5 rows from there on. And this is where, if we do a little change here, we, for example, remove the label in this case. Nope, that wasn't what I wanted. I wanted to do that. And we run it again. You'll now see that it estimates 172 rows, because it's actually going to go through every node in the entire system, whether or not it's a movie or not, and look for the title, the matrix. So just a tiny little change, like adding, hey, let's filter on movie before we start anything, goes from 172 estimated rows in the first thing down to 1 estimated and 5. And we can also look down here a little bit of cost, but if we want to have more information, instead of doing explain, which is like a query planner, we can actually go ahead and say profile. If I run profile, it does the same thing, but it actually does it in real time with real data, and it basically tells us, here is the amount of memory I used, main page cache hits, database hits, how long it took, and all of that stuff, so we can really drill into it. And this is worth doing if you start doing your data and you don't know quite how you want to return or how you want to query it. Or you know how you want to query it, but it doesn't fit with your model, and then you might have to go in and change and say, oh, this query here that we run really often, we probably need to turn that into a label thing instead, because labels are always indexed, so they work really well, but doing a property query is a bad idea, for example. So I find that there's a bit more to think about from a performance point of view with neo4j than I would normally think about with SQL, because SQL can basically handle most things because you just add a couple of indexes and you're done. Removing data is another thing we often do. Deleting a node, once again, you just do match your node, delete p, a node in this case, and it deletes it. Now, little caveat is that you cannot delete it if there are relationships. So in SQL Server has the same problem. If you have a foreign key, you can't delete it unless you have a cascading delete on it. This thing will just fail. You can't do cascading deletes. So what you need to do is, instead of just calling delete, you do detach delete, which tells neo4j to say, this node here with Charlie Sheen, can you please take and just kill all the relationships that is involved with this node and then kill the node for me? And that deletes that node for you. You can also run this query. I wouldn't recommend it, because if you look at it, match parentheses n means match any node in the database, and detach delete n means take away any relationship for any of those nodes and then delete the nodes. That is literally truncate, not my table, but truncate my entire database and just kill everything. Sweet command to run for your dev environment and your local thing. Very bad to do if you're in production, like most deletes are. Relationships, delete in the same way. You do a match, and then you delete the relationship instead. You can also delete all relationships. Actually, it's not all relationships, it's all acted in relationships. I should have removed that. But you can go and say, if we had removed, actually I can fix that right now. If you do this, that was what I wanted. Stop. Here, I fixed it on the spot. If you do that, it will delete all the relationships from Charlie Sheen to anywhere else. Removing data, I'm not going to do a lot of removing data. I've only got 12 minutes, and I want to show you some C# code on this as well. But I do know that, can I move, here it is. I do know that neither me nor Emil was actually in the matrix, if you thought so. So what we're going to do, I'm going to remove me and Emil from the matrix. So we'll do match, we'll do movie. I'm going to start by selecting so you can see that we're actually in here. Actually, we can do, oh yeah, we'll do that, sorry. What I'm going to do is I'm going to do a fat match movie with the title The Matrix. And then I want to find any node where we have acted in. And then I want to pull out the node at the other end. And for some reason I decided to add person here. We can do that. And then I'm going to return P. Now, if I run that, we can see what I saw before, that Emil and me were both in the database, which is what we don't want. So we want to remove us. So what I'm going to do is I'm going to go into this again and say I'm going to match that. And then I'm going to go and say where p.name equals, and I'm going to try to spell this correct because I keep writing email instead of Emil. Look at that, I did. Emil Eifram or p.name equals Chris Klug. And then we just do, need to get hold of my relationship, so I'm going to assign that to the R property, or value, or our variable, and then we do delete R. Run that. 2 relationships deleted. And then I should have kept my previous query. I think I can go back and get it again so we can see it. So we get, once again, we pull out anybody who's acted in the database, or in the matrix. We can see where me and Emil are now gone. And we're still here as nodes. So if I go and find match any person, where p.name equals Chris Klug or p.name equals Emil Eifram, return p. Run that. We can see that we're still both in the database. And if I wanted to delete me, which I don't know, sometimes want to do, we'll do person, name, Chris Klug, like that. We remove the where clause, and we do delete p like that, and it will delete me as well. So it's kind of not that hard to do. You just need to do your, once again, your queries, assign it to variables, and then do delete variable, and it goes away. Now, I have 9 minutes to do what I want to show you, which is why neo4j is actually really cool from another point of view, and that's traversing the graph. So you can write a query like this. So we do the match that we've seen before, but instead of adding an arrow there, I go curly brace 2, which says, I want you to go and find any path where it starts with Keanu Reeves. You're allowed to do 2 levels of acted in away from him, and then I want to pull out anybody who's 2 levels out as well, which basically gives me co-actors. Because the first acted in is going to be from Keanu Reeves to all the movies he's acted in, and another acted in is going to be everyone else who acted in those movies as well, which would be his co-actors, and then we can return the co-actors. Now, it will fail a little bit because it will return Keanu Reeves as well, so we'd have to filter out Keanu Reeves again because he would be in that path coming back as well. But it's kind of cool. We can also go and say the same thing, and then do return, and because it's a path, I'm selecting the entire path. I can then use the nodes p to get all the nodes in the path, and I can pull out the first node, which is 0, and I pull out the name, and I get that as actor. And then I get all the relationships, and I get the first relationship, and I get all the roles from that thing, and that is role. Then we go for the second nodes p1, which would be the movie in the middle. I get the title, and then nodes p2 would be the second, or sorry, it would be the third node in the whole thing, which then allows me to access the co-actor that's out there as well. So we can go ahead and use these nodes and relationships to traverse the node hard-coded like this. But we can also do shortest path. Shortest path is where we say, here is one node, here is another node, find me any relationship as far as you want to go until to find a relationship. So if I ran that, it would go ahead and give me this, where it basically says that Tom Hanks was in That Thing You Do with Charlize Theron, who was in The Devil's Advocate with Keanu Reeves. I can also ask for the shortest 3, which will give me 3 paths from these 2, which would return this. And it basically gives me that first one that I just had, but it also gives me Keanu Reeves in The Matrix with Hugo Weaving in Cloud Atlas. Sorry, no, that was not the same. Sorry. We have Keanu Reeves in The Matrix Reloaded with Hugo Weaving in Cloud Atlas with Tom Hanks. We got Keanu Reeves in The Matrix, same thing, but Matrix instead of Matrix Reloaded. That doesn't exist, so that movie that doesn't exist. Sorry about lying. And then Keanu Reeves with The Devil's Advocate and Charlize Theron and everything like that. So I've got a couple of minutes to show you how to do this. Hopefully I get it done in time. I have a little sample project here. It's just a very, very basic web application that I built. It looks like complete crap. Sorry about that, but it works. So what I want to do is I want to have two drop-downs. One drop-down where I get all of the, I select a person in the movie database, and the second drop-down I select is another person in the database, and then it gives me the line between those things. So I told you it's going to look ugly, but it's going to show me people here, and when I click that, it should give me a list of graphs, basically, or paths where I can find who acted with what and who and why to find the different things. So that's what I want to build. To do that, I'm going to start off by adding in a NuGet package, and the NuGet package that I want is neo4j.driver. We install that. Then I open up my pages where I have the thing that I wanted to do, which is in here. And we can see here that it's all hard-coded at the moment. I do need a configuration because I need to get hold of some config. And when you do configuration, you want to connect to a database. When it comes to neo4j, it needs a URI, in this case a database as well, because I have multiple databases, a user and a password. So the URI I can find by going out to my thing here where it has the connection URI. So I'm going to copy that, paste that in there. It needs a database name, and the database name was neo4j demo. It needs a user, which is going to be neo4j, and it needs a password, and that's going to be my very top secret password, 123 exclamation mark. Now I have my configuration, so I can connect. Now, in here, in my onGet, where it goes and sets up the people for the drop-downs, I'm going to go ahead and add this. I'm going to make this a sync task. So I create a driver. A driver is the thing that connects to the database for neo4j. And then we can do that, which is you pass into the driver, you go ahead and you pass in the URI, and then you give it, in this case I'm using auth tokens basic for it, so I give it a username and a password to connect to the database. And then we need to change this thing here, we need to add a little thing here. So what we're going to do is we're going to do var people result equals await driver dot executable query. That's where I pass in my query. Then we have to tell it with config, because I need to tell it that I have a database, a database name. So I'm going to do database colon name, and I'm going to do configuration neo4j database. Was that the name of it? I think it was. So I think that looks right. And then at the end here we do execute async like that. Now the query that I want to use is fairly simple. It's going to be match p colon person return p dot name as, and I need to do this as name with capital for reasons, and order by p dot name. And then once I've done my thing here, I've made the query, I need to convert it into an array that I need. So I'm going to do people result dot result to get the results, and then select. And then I want to do an x.asObject to cast it to a person thing, which is a class I have in here that represents a person, and then dot to array. Sweet. So now I have my people. On post, I need to do some other stuff, because now I've got a to and a from, so I basically need to figure, or a from and a to, so I need to query that thing. So I'm going to go neo4j 03, which is once again creating a driver like that. And then after we have that thing, we need a query. So I'm going to run a query. I'm going to show you how, I'm going to do it in here because I'm a little bit short on time. So what we'll do is run. Why did I not get the thing that I wanted? Why does this always happen when I'm short on time? So we want to neo4j. Why am I not even getting that thing now? I want to do. That's what I want. So here's my query. And the query that I'm going to run is going to be something that looks like this. Damn it, there it is. I'm going to do match I want to find the shortest path. I want to find the shortest 5. That is a person. But in this case, I can't hard code the name. So I'm going to go, hey, that, and then we're going to do name, $, $from. And then we want to match that with anything that is acted in, or, and here is where I need to figure out how to write a pipe. There it is. Or directed. And it's going to be another person here. So it's going to be P person. Actually, we don't want a P here. Person. I'm running out of time. Sorry. And then we'll do name, $, $from. And then return P. Now, thank you. It should be a 2. I love people who are attentive. So, person, name, from, sorry? Look at that. Mob programming at its finest. Thank you for that. So this should be about it. What? I should not be allowed to code, obviously. So I need to figure, that's the one. So I also want to do one thing in here. I need to pass in the parameters. And we have this thing called with parameters, where we can pass in a new object, like so. And we can say from should be from, which is a pass in from the front end. And to should be to, which comes from the front end as well, like that. And we need to change some stuff in here. Last little bit here. I'm going to change this with N4j D6. Nope, that wasn't it. Apparently 5, sorry. Why do I code worse when I'm stressed? N4j D5 is down there. I don't know why it's not in order. I need a little helper method that I'm going to add in. Let's add it here. 6. And then that came out with the wrong type of quotes. And that's the wrong type of quotes. Okay, let's go. Restart application. I choose Billy Cyrus to Carrie Fisher, and we do submit, and I missed something. I know why I missed, sorry. Give me 1 second. It needs a curly brace there. Can I get a curly brace the other direction? Reload again, come on. I did something wrong. Parentheses, colon, person. That's the one last attempt. My demo at the end here that should just show the whole thing coming together obviously didn't really work. Continue. Now the whole thing fails. Okay, let's try that again. Brooke Langton, no, don't know who it is. Chris Columbus, no, don't know who it is. And it fails. Sorry, all the code, this will hopefully redeem it a little bit. All the code is going to be available for you to try. I'm just running out of time, sorry about that. Few little things to think about quickly. You have constraints in there. You have a couple of different types of constraints. You can do unique on properties. You can do existence constraints. The only thing is that out of all these constraints, you can only use that unless you go enterprise, which is a bit annoying. You have to think about modeling a little bit as well. So the anchoring stuff I was talking about, whether or not you do labels versus properties when you do your queries, if you do denormalized data, which I don't recommend in a lot of cases because it's not great, and use your profile and explain. I am sorry for my demo failing. I'm over time, but all the code is here. Go ahead and download that and try it out. It's really cool once you try working with it. If you have any questions, feel free to come up and ask me. Thank you so much for listening.